Hello everyone, it's Angela, and today we're going to be going over problem 2 on your pre-Tuesday workshop, continuing on our adventures with ice tables. Now, as I read the problem, we of course are going to be highlighting the important information. So we have a flask containing initially only hydrogen and nitrogen. We're going to be having a reaction, and these two compounds will react completely. When it's finished, there are 4 times the number of moles of ammonia gas compared to the number of moles of the remaining nitrogen gas in the flask. We have our ice diagram below, and they designated the final number of moles of ammonia to be N, so it's written here. So the first thing we want to do, according to this problem, is fill out the 8 remaining tables, and finally, overall, determine the initial mole ratio of hydrogen gas to nitrogen gas. So let's do this sequentially, starting with the pieces of information that we know and then seeing what we can fill in after. So we know that the sealed flask initially only contains hydrogen and nitrogen. That means there can be no ammonia initially. So the initial line for ammonia is 0 moles. Next, let's address the highlighted blue. We know that there are 4 times the number of moles of ammonia gas compared to the number of moles of the remaining nitrogen gas in the flask. And luckily, we know the final number of moles of ammonia gas. So the final number of moles for nitrogen is 1/4 of this. So I'll designate that with 1/4 N, as multiplying these by 4 is just N. Now let's look at the purple highlight, in which it states that they react completely. In order for this reaction to go to completion, one of these elements must be used up, or one of these compounds must be used up. We know that it's not nitrogen, so it has to be hydrogen. So we designate for hydrogen that in the end, there are 0 moles. Almost forgot this too, very important. Now we have our end line all filled up. Let's look at our change line. Starting with ammonia, we go from 0 moles to N moles. So the change needs to be plus N. Now let's look at nitrogen. The ratio of nitrogen to ammonia is 1:2. So that means the change for hydrogen is half this number. So I will write 1/2 N. However, nitrogen is a reactant. It's being used up. So instead of addition, we will use subtraction. Now let's look at hydrogen. The ratio from hydrogen to ammonia is 3:2. So we'll need to divide this number by 2/3. And when you do that, you will get that the change is 3/2 N, being subtracted, of course. Now we can finally get our molar amounts of hydrogen and nitrogen. For hydrogen, we're going from the initial to completely 0, so it's the same as our change line. So I will write a 3/2 N here. For nitrogen, we are going from an initial minus 1/2 to 1/4. So let's add these two together. This is a little bit of a mental math problem. You should be able to do this in your head. And our initial value is 3/4 N. So now we have our initial amounts. Let's create ratios between them from hydrogen to nitrogen. It would be nice if the denominators were the same, so I will do that to the side. You also be able to do this yourself in your head. So with the ratios the same, from from hydrogen to nitrogen, we have 6 over 4 to 3 over 4, otherwise known as 6 to 3. And this simplifies down further to 2 to 1. So this is our final answer for this problem. I hope you found this video helpful. Thank you so much for watching.